So hello everyone, and welcome to the encapsulation session at the Dataverse community meeting. My name is Anna Trišović, and I'm a postdoc here at IQSS. I work on problems relating to encapsulation and containers on the Dataverse project. And yeah, so before we start, I would like to thank Sandra and Craig for agreeing to be co-chairs with me today, and for putting together this very exciting program. And so this session has the following aims. So we want to talk about encapsulation and containers, and generate discussion that may drive future developments in Dataverse. So we will do that by listening to some expert talks and then having an open discussion at the later stage of the session. So in particular, this is going to be our agenda. So I'm now giving an introduction, and I'm giving a perspective from Dataverse point of view. So kind of like what are we hoping to do and what are the problems that we are facing. And then we're going to hear 4 very exciting talks. And afterwards, we're going to have an open discussion. Okay, I see people are still joining. I'm sorry. So what is encapsulation, and what do we mean by that? So container technology, or encapsulation, provides a way to visualize operating system in a lightweight way, and it can capture data code and its dependencies. So it is really popular for fast deployment of software on the cloud in the industry, but also recently it has become really popular for research, and in particular for preserving data and code, and it can facilitate reproducibility and reuse. Even more, it is actually considered to be one of the best solutions to enable reproducibility. So there are different types of containers, and they can describe different computing infrastructures. That means that it can describe computing infrastructures such as like a supercomputer or just a single TS. So it is a very versatile technology, and that's why we want to accommodate it in data repositories. Okay, so like a typical researcher probably wouldn't want to invest time to learn about containers and to learn how to use containers. This is why many new tools have emerged that kind of like integrate containers behind the scenes. And these tools are CodeOcean, Wholetail, Ranku, ReproZip, and you've probably heard many of them. However, there is a problem, and the question remains, like how to effectively preserve and disseminate this data code and container bundles once they are kind of like captured by this reproducibility tool. So in particular, many of these tools are like startups or are projects that have like limited funding. So it is important to enable that this data and code stay accessible in a longer term. Okay, I hope that makes sense. So Dataverse has tried to tackle this problem as it wants to also improve reproducibility on the data repository, and also wants to, in order to do that, wants to accommodate capturing virtual containers. So there is an ongoing integration with CodeOcean, Wholetail, Ranku, and Binder that would allow actually encapsulated research data and code to be exported on Dataverse. So here on the left-hand side, we can see this like workflow where a user would use Wholetail to encapsulate data and code that would then be deposited on Dataverse. However, on the other side, any user should be able to do this. So regardless of their use of reproducibility platforms or not. So on the right-hand side, we can see like a single typical user who just decided to learn to use containers, and he or she should be also able to deposit this data and code bundle in Dataverse. Okay, so here we can see more Dataverse developments, but actually this is Wholetail development. So they now provide enable users to import data, like Dataverse data, as external data inside a container on Wholetail. So I took a screenshot from Craig's video And this is how it looks like. And you can see more here if you click on this YouTube video. So on the Dataverse side, this is kind of like a preliminary view of the landing page for a data set. So we want, so yeah, this is kind of like a preliminary view. We would have like a drop down menu on the Explore button, and essentially users can look into this like data sets in CodeOcean or Wholetail or Binder without needing to download or everything and try to set up this environment, and to yeah, it would be much more portable and easier to explore this data set. So there is so this previous view was preliminary view. However, something has already been done, and that is on the Binder side. So this is the mybinder.org. So if you go there, you can put Dataverse DOI in this text box and launch a container and see what is inside a data set from Dataverse. Okay, and if you would like to find out more about new Dataverse developments, integrations, and all the problems that we face, I encourage you to have a look at our preprint that's now on archive. Okay, so let me reiterate the problem. So that we are facing. So data repositories and Dataverse have a long-term commitment for preserving research data and code. However, we also want to enable findability, accessibility, interoperability, reuse, so FAIR principles, and also reproducibility of research data and code. So if we decide to preserve the whole containers, data and code inside these containers would not be easily accessible. There is no existing metadata standards to describe containers, which is like a standing problem. And also this would be potentially very expensive for data repositories because we would need a new infrastructure to keep these containers. On the other side, when preserving just recipes or like Docker files instead of the whole containers, data and code would remain discoverable and accessible. So that's by design in repositories. And this would be implemented in a very inexpensive and easy way. However, container rebuilding and thus reproducibility would be compromised because Docker files can build 2 different containers just in a span of time. And yeah, they can also just crash and not build really anything. So that's the problem that we're kind of facing. And yeah. So what are the next steps for us? So we're actively searching for a best solution to store virtual containers in Dataverse. In addition to that, we want to describe other advanced computing infrastructures, artifacts, such as workflows, infrastructures, and containers in metadata, which now does not exist. And we also want to improve reproducibility of new research data and code, and also old research data and code. So we are very excited to announce that this work will be funded by the Sloan Foundation. So our grant proposal got approved yesterday, and we want to use this opportunity to thank them very much for recognizing the importance of this work, especially considering the whole Corona crisis and so on. So, okay, we can now proceed actually with expert talks. So I think I was on time. And yeah, so I will stop sharing my screen. So I think it would be great if you guys, everyone who has any question, they can post them in the chat, and then in the chat, and then me or the other chairs will actually pick up the question and ask the speaker, or try to answer the question. Okay, so now it is actually my great pleasure to introduce Tim Head, my former colleague from the Particle Physics Laboratory at CERN, where we both worked at one of the experiments at the Large Hadron Collider. So Tim was actually one of the first people to like bring up problems relating to reproducibility in particle physics. And at the time he created one of the predecessors to the current mybinder.org, which was very original. And today, Tim is part of the Jupyter Hub and Binder team. He's a project lead and also helps build and operate mybinder.org. So he is speaking to us from Switzerland. It must be a little bit late there now. So Tim, thank you very much for being here. And yeah, the floor is yours.
Thank you very much for having me virtually, because going in person, even without Corona, would have been probably too difficult. So yeah, as Anna said, I'm one of the people who spend their time helping run mybinder.org. So we'll talk a little bit about our experience of operating this service for, I think it's like close to 3 years now. So I want to start with a more philosophical point of what is research about? And I think, at least for me, the goal of research is understanding new things. So you want to figure out new stuff, and you most of the time start from somewhere that you already understand, and then you go somewhere new, and then this new place becomes somewhere that you understand, and then you go somewhere else. And you know, there's fantastic quotes like standing on the shoulders of giants and things like this. And then another thing I think is important to think about is this free as in freedom, which if you have been involved in the open source community, you will know they make a difference between free as in beer and free as in freedom. And basically what this means is that if you want to provide free as in freedom software, it gives people the right or the ability to take apart, inspect, reassemble, reuse, remix, all that good stuff, the software that you build. And I think for researchers who use software as a tool to do their research, then having a black box, even if it's free, where there's one button and you press it and out comes a result, really is not good enough. We need the ability to take stuff apart and put it back together in a different way. So for you who don't know what mybinder.org is, we tried to come up with a very short one-sentence summary of it. And the best we can do is that we say we're a global community of humans that operates mybinder.org and develops the open source software used to run it. And the software itself allows anyone in the world to launch interactive computing environments in the cloud. And the important thing is then simply by clicking a link in your browser. So we try and really work very hard to make it as simple as possible for somebody to run somebody else's code. And the simplest way to do that is make people click 0 links, but unfortunately that doesn't work. So they have to click at least 1 link. There's some impressive numbers there. That's mainly to convince you that this is not a niche operation, even though on the scale of the internet, it's not super big, but you know, it's quite a few people who use it every day. And at the bottom, you have a word, well, not from my sponsor, but to my potential sponsors. As an example, so this is a data set which is in the Heidelberg instance of a Dataverse. And these people, like Anna demonstrated before or alluded to, you get a DOI for your data set. And if you take that DOI and we wait for the GIF of the live demo that I thought I would be smart to record. Wow. Okay, well, we'll have to make an actual live demo because the recording of the live demo doesn't work. So you go to mybinder.org, and then I will not demonstrate, unfortunately, how to access a Dataverse dataset because I don't know off the top of my head the DOI for this particular dataset. But you have a drop-down menu here where you can select lots and lots of different sources of files in that sense. And so one example is a particular GitHub repository that we have, which we use as an example. So here, instead of typing binder example /requirements, you would type in a DOI, and you press launch. And then if the demo gods are with us, in a few seconds, in the background, mybinder.org does its magic of building a Docker container for you, and then it launches it and connects you to it. And then in the dataset example from the people in Heidelberg, and you have the data files that they put in their in their deposit, but they also added a notebook in that case. So it's something like this one, with which they promise that you can reproduce the figures that they made for their publication. So this one is not super exciting because it just makes some fake data pictures, but you can imagine if there was actual data in this repository, and then there was a notebook with it that says, if you run this notebook, you will make figure 2 and then figure 3 and then figure 4b and so on. And all you have to do is click a button, then you're getting, you're making a lot of progress. And then you can, within a few minutes, hopefully decide that, okay, this works as advertised. I now have an example that I can edit and do something else with the data, or take the data and replace it with my data and use the method that the people originally attached to this deposit on your data. And for me, that is, the reason to run something like mybinder.org is that it makes it very, very easy. It removes all these endless email threads about trying to discuss who can't write instructions or who can't follow instructions. And so Philip Durbin and friends did a lot of the work that makes it possible to just take a Dataverse DOI, type it into mybinder.org. So a great shout out to him. There is a GitHub issue where they are discussing how to extend this. So if you're interested, follow that. And then to make it more general, Binder works with any directory of files. So what this means is that anything that we can make look like a directory of files, so be that a Dataverse deposit, a Zenodo record, a Git repository, a zip file, what have you, it will work with that. And the way we do that is that we then inspect this directory of files and try and find files from which we know that the community uses them to specify how to install software. And then we generate a Docker file from this, and we execute it and build a container image from it and launch it and connect you to it, etc., etc. And I think that's very important, because if you look at the Docker file that was generated for that very, very simple data set in the Heidelberg Dataverse, it's, I think, something like 140 lines. And that's to install some fairly simple pieces of software. And the reason it's so long is that writing a Docker file that will stand the test of time and still work, or still has a reasonably high chance of working in a few months, in a few years, actually requires quite a lot of sophistication. And this is why we think automating that process is much, much better than trying to teach people how to do it. I could not recite to you more than maybe 3 of the lines in this 150 lines off the top of my head. Okay, so this is the end of my talk. And some questions that I think would be interesting to discuss either now, if I've not used up all of my time, or if we want to bundle all the questions for the discussion later on. So these are some things I think would be interesting to go into more depth with the benefit of knowing a little bit more about all of you, because that's the, how do you call it? The problem of somebody who doesn't know anybody at the meeting is, what level do you start with? So yeah, hopefully we will get to know each other a little bit more during the session, and then we can talk about these things or go back to anything in the slides. So thank you.
This was so interesting. Thank you so much. I think that these questions are great, and I think that maybe you can copy them into the community notes, so then everybody can see them, and they can also, these notes are like shared among all the participants, so everybody can maybe like write their own response or something. So would that make sense?
Yeah, of course. Should I put them in the section for my talk, yeah? Or should I put them in the discussion questions section?
Yeah, there is I will share that link actually in the chat. So there's a public like note taking. So maybe Michael, can you share this, or Katie? You can share maybe this like note taking document.
Yeah, it's already happening, Anna, by the magic of the crowd. Somebody has started typing them. Thank you.
Okay, perfect. So yeah, are there any questions for Tim? Okay, so there is one question on singularity, but maybe we can keep that for a little bit later. So I have maybe one question. So yeah, you mentioned that we can drastically improve sustainability of Docker images if we have like automatized way of creating these Docker files. Do you think this tool, such as like CodeOcean or Wholetail, can help with this? So in a sense that instead of a user creating a Docker file, this like automatic, these like tools can create the Docker file, and then they can be much better than the ones that the user would create. Does that make sense?
Yes, and the short answer is yes. So for one of the tools we built to run mybinder.org is called Repo to Docker, and it does exactly what you described. We decided that it's too difficult, even for experts, to write good Docker files, or not too difficult, it's too tedious, maybe is the better way of putting it. So Repo to Docker is what does all the magic of inspecting the set of files. And I don't know anymore whether Wholetail also uses Repo to Docker or not, or whether it's still an option. CodeOcean also at some point used Repo to Docker. So I think, yeah, this is something that's worth using and investing in.
This is Greg, and I can answer that we certainly do still use Repo to Docker. So Wholetail still does, for sure.
Okay, that's great. I thought that it actually does not, it actually only builds, well, I think that it only like creates Docker files if everything is already specified, but I didn't know that there is like that it actually helps the users to create this like more sustainable environment. Yeah. So yeah, I was just trying to say that I thought that actually everything needs to already be in place for Repo to Docker to work, but not that it can automatically recreate this environment. So we can go to, again, thank you so much. And we can go to the next speaker. So our next speaker is Johan Cochran. He's the Digital Preservation Manager at Yale University Library and PI on the Emulation as a Service Infrastructure program of work. Johan has been working with emulation since the 90s and is passionate about ensuring our software heritage remains accessible for the future generations. Yeah, I've heard so much about the EASY project in the last months, and I'm very excited about this talk. So yeah, Johan, thank you very much for being here. And yeah, the floor is now yours.
Thank you. Thanks for having me. Good afternoon, good evening, good morning. I'm currently 9,000 miles away, so it is good morning from me. So as a warning, I'm on a fiber connection here, and hopefully everything will work out, but if it doesn't, it might be because I'm so far away. So I also got fairly last minute invitation to work on this. Someone else is going to do it as well, but so my slides aren't quite as refined as I'd like, and my talk may not be. We're going to try and get through it all in 10 minutes, but I will also share the slides, and they have a bunch of embedded videos, so anyone will be able to take a look at those afterwards if there's anything that's missed, or if you have any trouble with my accent or anything like that. So emulation as a service infrastructure. We're focused on the long term of software access. And we're tackling problems in relation to research software like these. So often original code in experiments in research is tied to legacy software. Often that software is difficult to find. When it's proprietary, it can be difficult to package with reproducibility packaging tools. Most of them don't really work with Windows very well. There's a lot of talk today in particular about containerization type tools, encapsulation tools. And is there something going on in chat that I should be aware of? And they may no longer be supported in the future on certain operating systems. So what I mean by that is the actual runtime that's used to run the Docker package, say, or ReproZip may rely on kernel features in the operating system that it's running on that may no longer be there in the future. So it's important to be able to have a solution for keeping those available in the very long term. And that's one of the things we're tackling. And there can be a lot of challenges preserving and using software that's either not being published commercially or is only published to a very small community, and it may be difficult for future users to understand. So I appreciate what we just heard in the last talk about needing to capture all of the steps used to get something running, because for us, we're doing that for a lot of legacy software. We're pre-configuring a lot of legacy software, and that takes an awful lot of time. So I absolutely agree that it's really important to be able to capture that. So those are the kinds of research software issues we're tackling in EASY. The goal of EASY is to deploy and scale infrastructure for software emulation. And we're using a tool called Emulation as a Service that came out of the University of Freiburg, which allows you to access emulators in browser that are pre-configured. And it removes that issue of where do I find the emulator, how do I configure it, and how do I use it? It's all pretty straightforward and done via a web-based interface. And we're building on that. I thought I'd show a quick demo of one example where what we've done here is taken one of the ReproZip packages that's on the examples page, put it into a environment in EASY, so a software environment. In this case, it's a relatively new version of Ubuntu, and rerun the package. This takes about 2 minutes, so I'll skip ahead. So you can see it running the repro unzip command. It'll briefly show the, I think, Postgres server starting, and then switch to Firefox, because this particular package is, it creates a website, or it's captured a website, and the server required to run that. I'm skipping ahead. There we go. So it's starting Postgres and everything else. And then we'll see, we get a local host, and you get the access to the website and the functionality of the website, so you can go through and click things and so on. Do whatever you need to do to look at how that website worked. So that's all running remotely and accessed via just a regular web browser, which makes the very low barrier to entry. As I said, EASY is simplifying access to emulators. We're also creating what we're calling the EASY network, which allows people to create a software environment and share it with other organizations in the network. So it solves that problem of finding and configuring the legacy software, because other people are contributing pre-configured environments. And this is all being hosted, the project is being run from Yale University Library, and we are populating the network with thousands of pre-configured environments and applications that we got from a collection. We're doing an awful lot of work with documentation for both the environments and the software, and all the bits in between. And there are some links in here. As I said, these slides we shared, but we're doing a lot with Wikidata, which I can't recommend more. It's an amazing resource. But if you're interested in getting started, have a look at those links, particularly the second one. There's a lot of pre-configured queries related to research software and digital preservation, which would be really useful, I suspect. And one of the things we're doing is we're capturing every input, output, save, export format for every application that we're preserving and making available in EASY. and we're using that for driving lots of different things in the front end. So on top of all of that, so we have this ability to run the emulators, access them in browser, share pre-configured computers and environments. So we're taking all of that and adding some services on top, including a virtual reading room service that allows you to assign a computer to a user for a period and control what they're able to do in terms of get data in and out. We're doing a thing with CD-ROM publications, some basic workflows around scientific software. And the last one is probably it's quite an interesting one. So this one, I'll skip straight to the demo here. Basically, it allows you to submit a digital object. This is just one example of how you could implement it, because this is really a set of API functions that you can implement however you want. But you submit a digital object, it analyzes it, it recommends pre-configured environments that will run it. And then you can choose to present one of them to the user, or you can have a menu like we did there, and the user can select. It'll open. What happens is a little script is created automatically that runs on startup, and then that opens the file in the operating system. You can see it there. And then we'll see in a second that there's an option to select the other environment and have it open in that with the button that you can embed in your own software. This example uses Excel as, or Excel version 3, an Excel version 3 file, but we can put SPSS, data, SAS, any kind of software you want in these environments. And the interesting thing about this is when it opens in Excel, so we just saw it in Quattro Pro, the same file open in Excel, you'll see a different piece of information appear that wasn't visible in the other software. Showing that it really is important to have the right software when you're opening these kinds of files and interacting with them. And then it also shows that we can save to a different format and export that file. So you can use this for migration via emulation. So if you need to get data out, you can do that. Yeah, so there's the contents of the disk got exported there. So that has the file that we saved in it. That's how it works. Feel free to have a look at a later time. We're doing a lot of work to improve the UI. We just released a new version to all the node partners, which makes it much more easy to find the software you're looking for, find the environments you're looking for, and also adds workflows for documenting them thoroughly. As part of all of this, we're creating standard ways of documenting the different components, as I mentioned. Those will eventually be published as in some form as some sort of standard from Easy, and there will be an API to find that information from the database, some of which will definitely be public, and a lot of the rest of the metadata we're creating is going into Wikidata. All right, some things for researchers, so you can access and reproduce legacy research using original code, access proprietary software, export data, and access things like databases via a secure proxy. Here's an idea of how it could work for data curation. So you could take an environment, add some code, make sure it's working, save that environment as a new derivative, and get a handle in a DOI that you can then share and publish. Or we could take a container from CodeOcean, from anywhere really, and rerun it in Easy once CodeOcean no longer supports those older packages, or whichever service no longer supports the really, really old packages in the distant future. We're doing some things to improve automation in the future. We're going to make these environments addressable via an API, so you can do automated interactions and automated package reproduction, as I said. So we can just take a container, we'll run in the background an emulator with the right operating system and kernel features and so on, and have it automatically run the package and get the results back out to you as kind of a workflow process. And we're doing a thing with networked environments. I don't have time to show that video, but I'll leave it in the slides. But what you'd see there is two computers networked to each other, but isolated from the public internet. If you want to get involved, here's a few different ways. Take a look at the website. You can try Easy, it's open source, but there's also a sandbox online with some open source software in it that you can play around in. And definitely take a look at Wikidata if you haven't come across that already. We have a great team, and we have some great funders, also the Sloan Foundation, so thank you to them, and thank you to the Mellon Foundation also. So thank you, everyone.
This was really fantastic. Thank you so much. So any questions?
It looks
please
like
unmute
Greg
yourself,
might
yeah.
have a question in the chat. Greg, if you want to unmute yourself, you can ask it.
I guess I'm just
Asked
curious
it in
about the general issue of security concerns. I'm imagining that old software may have significant security holes that got patched later, but how do you deal with the legacy software?
So basically, we have the option to turn on or off internet access, and we can put pretty thorough firewalls in between. So we can make it so any of the machines in the in Easy don't have a network connection at all. So it makes it much more difficult to get into them. And then the thing I mentioned towards the end there is we can take two machines, network them to each other so they can share data, say a web server and a front end, or a database and some sort of front end client, and isolate those from the internet and from public access as well, which really thoroughly reduces the potential attack vectors.
Thank you. So I suggest we go to the next speaker right now so we can try to be on time. And then maybe we will have like at the end, again, 5 minutes, like a little bit of a discussion all together, and then anyone can ask any of the speakers questions. Would that make sense? Okay, so our next speaker is Vanessa Sakat. She is research software engineer for the Stanford Research Computing Center. She received her PhD in biomedical informatics in 2016 and stayed at Stanford to focus on open source software development for reproducibility. She continues to be passionate about open source, container technologies, system design, and most importantly, having fun. She talks about these topics and also many more at her podcast, RSC Stories, that I highly recommend. So, Vanessa, thank you so much for being here. Take it away.
Sorry, it took me like 5 minutes to find the unmute button. Can you guys hear me?
Yes, now we can hear you.
Okay, great. Let's get this show on the road. Can't see here. Oh, there's the right button. Technical difficulties, folks. Huh, it's not working.
Do you want me to share your slides?
No. Okay, let's try that again. I just opened it.
Yeah, we had a little bit of time allocated for this.
Gosh, it's never had technical difficulties before. Let's try this
You'll have
again.
to speak fast.
Yeah, great.
It's okay. It's okay.
Okay, now can you see?
Yes.
Okay, excellent. So let's get started. Like I've already been introduced, I'm Vanessa. I'm a research software dinosaur at the Stanford University Research Computing Center. And today I'm going to be talking to you about another really cool encapsulation strategy, singularity containers. So for a lot of you, singularity containers probably aren't a new thing. Actually, singularity is kind of old news, but we're still going to start with a quick overview of singularity. Perhaps you need a refresher. We're then going to talk about what I think this group is curious about, which is discoverability. How does singularity enable discoverability? Finally, we're going to talk about something that I think is really exciting that we need to bring back into discussion, data containers. So, what the heck is a container? A container is an encapsulation of your environment that includes an operating system, programming languages, and libraries. And if you're a scientist, it probably includes your life's work too. And so if you remember back in 2014 and 2015, this is kind of what containers felt like for a scientist. Docker was this new emerging container technology that promised to solve all these problems with reproducibility, but then you go and you ask your system admin to install it on the cluster and sorry, we know it's really great, but we can't install it because of these security issues. Darn. So the issue is that scientists need containers too. And so this is where Singularity came to the rescue. And so the problems that Singularity solves are generally reproducibility and archive of software and environments. You can put the entire operating system, your analysis, your special scripts into a container. And by the way, a container isn't this set of hidden layers on your operating system like with Docker. A container is a single file. It's a portable and shareable binary. You copy paste it, you share it with your colleagues. all in this nice little package. And it also has great integration with traditional HPC technologies, so seamless environment and also technologies like MPI. Finally, this is a huge deal for security. The user inside the container is the user outside the container. So you're not going to shell into a container and be like, hey, I'm root. I'm going to do something malicious now. So if you want to build a container, a Singularity container, you start with a Singularity recipe. And if you're familiar with Docker, this is like a Docker file. So for this example recipe, we're saying, okay, I want to start with Docker layers, specifically from Python 3.7. I'm going to write all the commands that I want, all the software that I want installed, et cetera, in this post section. And then in the run script, I'm going to write the command, what I want to happen when a user executes the container as a binary. And so let's jump right into what this group cares about. What about provenance and metadata? Or more specifically, how does Singularity enable discoverability? So the first very important thing is inspection of metadata. So let's look back at that recipe. If you write a little label section like maintainer is dinosaur, this software version is 1.0.2, whatever, then when you actually build your container, you can run singularity inspect container.sif, and here at the top we see our two special little labels here, and then there's some default ones provided by Singularity, like the definition file, the bootstrap, the version of Singularity, the date, et cetera, et cetera. And so the other helpful thing that this inspect command provides is a help section. So you can literally in your recipe write text like, hey there, friend, here's how you run this container. And then your user can literally ask your container for help and have it show you how to write it. But I have a feeling that a lot of you have run into a particular issue, and it's around this idea of, is the entry point discoverable? And it was kind of alluded to earlier, like what happens if you have a container with multiple entry points? And this is like default because on the one hand, you want to have one container, so it's a reproducible binary. But on the other hand, if you're packaging everything in here, what if you have 3 steps for your analysis pipeline? But there's only one entry point. So the result is you get these entry point scripts that look like this. If, else, da, 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 and it gets super complicated. And so I started thinking about this problem back in 2018. And to make this question more direct, how do we create internal modularity for a container? I came up with a solution called the scientific file system. And the idea of the scientific file system is that you can install it in any container technology. It's implemented natively in Singularity, but it's agnostic to the container technology specifically. And then when you see this traditional model where a container has one entry point, a big chunk for metadata, and then somewhere for content, your software and your libraries, the SciF approach basically creates this internal modularity. So in this example here, we see 3 apps, foo, bar, and hello world. And each app has its own little section for metadata, its own little section for libraries and executables, and still the shared global content. And then if you look at the top, the entry point is this SciF controller that will allow the user to say, hey, I want to run foo. And then the SciF controller says, oh, we're running foo. We're going to activate the environment. We're going to add the libraries to the path and the binaries, and we're good to go. And so the way that you build a scientific application, you can do more than one per container. It looks a lot like a Singularity recipe. So this will show you how you would, for example, build the Hello World app. And you'll notice that there are the very same sections that you have for a Singularity container. You can specify environment, labels, help, et cetera, et cetera. And so if you're a developer, you write this in a recipe.scif, or as I said, it's natively in Singularity, so you just put it in the Singularity recipe. You then install it in your container and you interact with it. What kind of interaction? Well, you can ask to list apps, you can run an app, you can execute a command to an app, you can ask an app for help, you can inspect one, you can shell actually into an app, or there's actually even a Python shell. So in summary, Singularity containers have inspect for this global metadata and labels. There's also help, so you can give your user very friendly instructions that are user readable, more so than machine readable. They are read-only containers, single binaries called CIFs, which makes it really very reproducible because you carry everything with this single container. And SciF, the scientific file system, is natively implemented in Singularity. Okay, so let's talk about something I'm really excited about, data containers. So this idea of data containers isn't anything new. This discussion started back this is from 2017, but we probably talked about it before 2016. And so I wanted to bring it up again for this community because I think now is the right time to talk about it. So if we step back and we say, okay, if a container has an operating system, what would a data container be? Well, maybe it would just have data. But then we sort of run into some other problems like, oh, but then how are we going to list stuff? How are we going to interact with the stuff in the container? That doesn't make sense. So what I first did is I stepped back and I said, okay, what are the features that I would want for this data container? There's a couple of things. I would want to try to have exclusively data, no operating system, taking up too much room, get out of there. I would want to still have an ability to query data and search it. So we would probably need some binary to be an entry point to do that. And I'd also obviously want to bind the container as a volume so I can, use the data. And so I came up with, just in this past week, this container database CDB metadata extraction tool. And the idea is that you can have your data and need it too. What it's basically going to do is use multi-stage builds and create a binary that will create an in-memory database that will index and let you search your data. So let me show you quickly what that looks like. And this is the Docker file. I realized after the fact this is a Singularity presentation. The equivalent exists for Singularity. So there's 3 stages here. In the first stage, we start with a Python base. We install the CDB, this container database software. We then, not surprisingly, we add our data to the root at data. And then finally, we run the CDB generate, targeting the data, and an output file, this entrypoint.go, which is going to be a Golang script that we can compile to create this in-memory database and index the data in data. Stage 2, we need to compile the thing. So that is literally all we're doing here. We're carrying forward the entrypoint.go and the data, and we're compiling it into a binary. And in the final stage, note that this is from scratch. Docker scratch is sort of like, you can think of it as an empty image. We're adding the entry point, we're adding the data, and we're making it, we're defining the entry point. So let me just quickly show you what that looks like. If you just run the data container, it's just gonna spit out the files and whatever metadata you defined. You can also just list stuff, so like a traditional file system list. You can search, so for example, here we have an indexed parameter size, so we're searching based on size with 8. And then you can also get, so you can get a very specific file, like all the metadata for it, or do a partial match to get more files. Or in many cases, you might want to have the container run alongside other containers, like with Docker Compose. So you need a command to start it and just like keep it running, basically sleeping forever. So why is this so powerful? This is really powerful because this entry point function that I wrote is pretty stupid and simple, but you realize that they can be optimized for the data set. It can expose inputs, it can expose a workflow, it can expose whatever you need to interact with the data. And obviously the metadata extraction can be customized too. For example, for a specific standard, like if you're in neuroscience, you might use bits. And obviously the container can be bound as a volume. So if you take away only one thing from my talk today, I want you to start thinking about what a data container would look like for your domain of science, for your use case. And then please, let's talk about it. Reach out to me. There's my email on VSOC on Twitter and GitHub. Let's build some data containers. That's all I got.
Thanks, Vanessa.
Perfect. Thank you so much.
Yeah, I have a question. We have maybe a minute. So how does your data container compare to Baggett? Because Baggett has also already a little bit metadata. You can pack metadata with it. You can transfer data. So how would you compare them?
I don't know what Baggett is, so I'm not sure I can answer that question. But I can say that a data container would just be a binary that doesn't have an operating system and has an entry point and just a query. If you want to send me a link to it, I can take a look and give you a better answer.
Fantastic. Thank you.
Yeah, maybe we can go to the next speaker, and then at the end we can come back and then ask any speaker any question. Our last speaker for today is Vicky Steve. She is the librarian for research data management and reproducibility at the New York University. She's also a subject specialist for data science. Her work centers on helping researchers of all types ensure reproducibility and sustainability of their work. She's part of the ReproZip team, and this is like one of the most prominent reproducibility tools out there. Vicky, thank you so much for being here today.
Yeah, absolutely, my pleasure.
Yeah, let's give the word to Vicky.
All right, I am gonna start in pretty quick. So I'm talking about the ReproZip ecosystem, which is comprised of kind of 2 tools right now. But first, I just want to start us off with some of the challenges in reproducibility that we are going to face. So the first, this little band-aid, is the human problems. So the things that, like, people make mistakes and it impacts their research. And that's something that I tackle in a different way with classes and things like that. What ReproZip tries to tackle is this daemon computer problem, which is that it's hard to keep track of what versions of software is used. People will say pip install pandas and then try and run it later, have no idea what version they used originally, can really mess things up. And then, yeah, these software get updates, and this technological change can really disrupt reproducibility. It's why we're all here. So we have this problem that technology changes affect reproducibility, but to me, I always frame it as this pipeline problem, where reproducibility takes a certain set of skills that are not really included in most curriculums. We're not teaching people this is how you need to work to be reproducible to a really large extent. And you can see there's been some research about it that I have quoted there. So this is the problem ReproZip tries to solve. You cannot expect people to write down all of the chains of their dependencies. Pandas relies on this, relies on that, relies on this in my operating system. It's just too much. There would be no way for a human to do this with any sort of fidelity. So the gap that we're trying to solve is a tool that can automatically capture those chains of dependencies called dependency hell automatically, and then automatically set them up in a completely different environment. So this is ReproZip, the reproducibility packer. What it does is it captures the necessary data files, environment variables, etc., workflow required to reproduce your data analysis or your research workflow, and then you can send a ReproZip bundle to anybody. They can unpack it anytime, anywhere, and check your work. This is the full ReproZip-ReproServer ecosystem, where you would run ReproZip on your local computer, and it takes 2 steps to create this RPZ bundle. This RPZ bundle can then be uploaded to a data repository, OSF, Zenodo, Dataverse, or just emailed to someone. They're typically under a gig, so they're very portable. And then you can either unpack it in your browser with ReproServer, which provides also a permanent link to an unpacked environment, so it helps facilitate peer review as well. And a permanent link to research results, so you can interact with and explore the contents of the ReproZip bundle in browser. Makes it very easy for folks. Or if you want to do it on your local computer, you can also do that in 2 steps using some of our unpackers, which are basically like plugins to create the original environment based on a huge metadata file in the ReproZip bundle. So to be more precise, if you're an author and you want to pack your research with ReproZip, right now you can only do it on Linux, but thanks to Ewan giving us a hot tip, Windows might be coming soon. So basically you would run your script like normal, only you would prepend the command ReproZip trace. So it'd be like ReproZip trace python myscript.py, so we're not trying to interfere in your workflow. While your script is running, ReproZip is tracing every single dependency. It's tracing your workflow. So if you're running 6 scripts in a row, it will know which script to run first. Creates this really intense configuration file, has really in-depth technical and administrative metadata, and then it generates this ReproZip bundle, the .rpz file, which is like a fancy tarball filled with all this stuff. ReproZip can pack most anything, graphical tools, like we have a huge Java desktop program we were able to pack. Ewan in his demo showed a client-server application, like a data journalism application, MPI experiments, which is a little bit complicated to set up but doable, and many more. We even wrote a little plugin, sorry, the image is fuzzy. So if you want to install ReproZip Jupyter, in your Jupyter notebooks, you'll get a little ReproZip button, and when you click that, it will run your notebook top to bottom and generate a ReproZip bundle that contains your workflow set of steps, everything I just mentioned for your Jupyter notebook. But so we've tried to integrate with a lot of different tools that other people are using also. So once you have this ReproZip bundle, which again is anything and everything you need to reproduce your workflow, you can then send it to someone who can unpack it in a variety of environments. You can generate a huge provenance graph if you want to see the your workflow steps. We had a student contribute a Singularity unpacker that Remy is working on merging in, so you can unpack it with something like Singularity. Or if you're on Mac or Windows, you can use Vagrant or Docker. But the thing about ReproZip is that it doesn't necessarily rely on things like Vagrant and Docker. Those could go away tomorrow, and as long as there was some virtual machine, some container system, or Linux, then you will be able to reuse ReproZip bundles. For context, ReproZip has been a project since 2012, and you can still reuse and reproduce the work in ReproZip bundles from 2012. So 8 years is, in digital preservation land, is pretty good, even though it may not sound super impressive, but I'm pretty proud of that. So ReproZip-ReproServer is basically the other half of the puzzle. So with ReproZip, you generate the bundles, and then you can reproduce them in ReproServer. You can do all the same things you can do locally, change the input data, download the output data, give it command line infrastructures. It gives you a URL to include in your papers. It offloads archiving to people who are good at it, the people who run repositories, and there's no lock-in. You can build on your laptop, pack anywhere, unpack anywhere. So ReproZip and ReproServer together are providing both preservation and access to these preserved environments. So ReproZip is the local, non-locked-in, reproducible way of packing research, and ReproServer is the way to really easily review, access, and reproduce the contents. It's also open source. It can be run locally at your institution, and it can read ReproZip bundles from wherever they live. So if you already have it in a repository, you don't have to re-upload it somewhere else. Our approach is good for preservation, first because it's well bundled. So as your like myscript.py or Julia myscript.j is running, ReproZip captures everything that process touches. So everything that it needs to run is there. The second reason that's generalizable, so the RPZ format is simple but effective. It can be interoperated, read, and accessed by many software, as we saw from UN, even in easy. And then, like I said, it's future-proofed. So as long as there is some virtual machine or container or easy or Linux system, you will be able to reproduce the work in ReproZip bundles. So it is an extremely sustainable approach to capturing this work. We have partnered with a few journals, Journal of Number Theory, Complexity, Information Systems. Like Ewan showed you, you can unpack ReproZip bundles in easy. We've also added some web archiving toolkits to ReproZip to be able to archive data journalism applications. So it's a pretty extensible set of tools. This is a bunch of links. I have a ton of cool things for you to see on YouTube, so you can check out some of our demo packing, unpacking, and ReproServer integrations. And then I'm a librarian, so obviously I care a lot about repositories. And so I wanted to talk about the way I see repositories fitting in. But first I wanted to make a plug for Sarah, which I don't think enough people know about. Sarah is this wonderful program that's developed at the University of Constance. It's a web service that extracts files and metadata from Git repositories and basically pushes metadata into a DSpace repository right now. It's a really interesting way to include the development history of code and of research artifacts, basically by cloning it to an institutional GitLab and then pushing the metadata into a repository system. In my perfect world, Sarah would integrate with all repository systems, so I just want to make a plug for working with the Sarah team. It's a very, very cool project. But anyway, on to my dream. This is my dream repository page. You might have your awesome institutional repository with a beautiful logo. You are a researcher who has deposited something that has a wonderful, catchy title. And it might have a list of great things, ideally some documentation, an RPZ bundle, some data, some code, some interesting metadata. But then most importantly, I think repositories can do a really great job of integrating and surfacing the work that we're all doing. Like, there's an RPZ bundle, could be a cute little button that says reproduce this with ReproServer, and it will, when you click that, it'll be like Tim was saying for Binder, that one click, open it up. You could deploy it on the HPC, open the sandbox environment with easy, extend the work with Binder, see the development history in software heritage. Like, I would love to see those one-click solutions for our multiple tools integrated right into the repository space. So I have 15 seconds left according to me. I have a small unrelated call to action, which is please take my survey if you use Git for your work. And in summary, ReproZip provides a way to create those fully reproducible bundles in a generalized format, and ReproServer, oh, my timer. ReproServer provides easy access to those. Thank you to all those people and everyone here for listening. And that's what I got.
Thank you so much. This was really great. It was super interesting. Yeah, okay, so maybe we can now use 5 minutes and then everybody can ask questions and our speakers and chairs can try to answer this. So maybe we can do that, and then after that we can like we can create some breakout rooms and a little bit have a more active discussion. So any questions?
There's a question from Christina. And I think Vicky already answered it also in the chat, but maybe just that everyone can hear it.
Yeah, so the question was, oh, sorry, Sandra.
Oh, no, that's fine.
The question was about how easy are any of these solutions for your typical humanities researcher? There is no typical humanities researcher. For those folks using computational humanities methods, Jupyter notebooks and our Markdown files in particular have been gaining a lot of traction. And ReproZip has the Jupyter plugin. So I would say if you feel confident in running a Jupyter notebook, then you could probably use ReproZip. So that's my answer. And I will link, we have an example from a humanities researcher in our repository of examples I can link in the chat.
Vicky, if you could also add a link in the collaborative notes so we can keep that forever, that'd probably be helpful too.
More questions? Craig also had a question, I think, for Tim. It was somewhere like earlier in the
He's
chat.
answered it already.
Oh, okay.
This is a question for Vicky. Have you guys integrated ReproZip-Server with any repositories yet, even locally? Like the...
Yeah, so we have ReproServer integrated with Zenodo, the OSF, Mendeley Data, and Figshare right now. For the institutional-based repositories, I assume we would need just like a DOI, and we have an open issue that basically lists a bunch of repository systems that we're hoping to integrate with and some pathways forward for that. So we have a few of the generalist.
Just to clarify, this is ReproZip-Server allows you to pull records from those repositories, not that you have direct integration into those repositories, like a button, your dream button of opening RPZ.
My dream button does not exist yet. I want it to exist, which is why I pitched it to all of you. But you can pass like server.reprozip.org/osf.io/ your 5 characters, and it will start the reproduction process for you.
Good.
So that could be the one link for like someone would add in a supplementary materials section.
Right, but that's so the external tools and something like Dataverse is an actual exception to just be able to add right now. Great, thank you.
Okay, if there's no more questions, we can then have maybe 5 or 6 breakout rooms, and then yeah, have a little bit of a discussion and write some notes. Try to answer these questions and many questions that the speakers asked. Hello, everyone. I hope it was fun to be in the breakout room and that you had some like productive discussions for 10 minutes. So maybe we can quickly summarize what was in each of the breakout sessions, and then yeah, and then finish with it. But so I'm also aware that maybe some of you will need to like leave now. So I just wanted to again like thank you to everyone for being here, and also the speakers. Thank you so much also for preparing like presentations, and we found you a little bit like yeah, we could have like reached out like sooner. Sorry for that. Yeah, and then we will also have like a social event at the end of the conference, I think, or maybe even today. I'm not sure. So I also encourage you to join that event if you want. So yeah. Okay, so maybe we can like have a small summary of what we were of each of the breakout rooms. Okay, so let's start with room 1.
I can try my best. We focused on the you know how do you describe and preserve the containers. We talked a little bit about Baggett and how it's mainly for data and metadata to store and persist the data, but lacks the environment infrastructure to reproduce, not for Docker files and containers. Slava gave an example of a SparkQL endpoint that he had been working to craft Docker images, and explained those, experimental and that it may not have the level of detail in the metadata that a repository would like to see. So then we started getting into more about those descriptions and the metadata and the challenges and how Dataverse basically accepts these files but treats everything like data, and that there are challenges that we need file level metadata and the ability to gather resources and preserve them all together, as well as the Selenium and other automated tests as well.
Thank you, Mike. Yeah, okay, so should we proceed with room number 2?
Yeah, so in room 2, we talked a lot about how we really appreciated out of the session that it was like a survey of tools. And one great idea from our breakout session from Sherry Lake was to think about creating a chart of all the existing encapsulation tools and their features for like a little side-by-side to help guide people's choices. We talked about how encapsulation software packs the mess, and how important it is to underscore good data management best practices on top of these strategies for preservation and longevity. So I think I'll leave it there. Our notes are in the group folder.
Okay, great. There was one paper that did like a survey of these tools. I don't know. It exists on the archive. Maybe I can follow up with that one. And
it's by David Wilkinson. Yeah.
Okay. Room number 3.
Sure. I'll be brief. So we spent a bit of time on the first question about supporting the FAIR principles. Thought for accessible did a good job. Reusable regarding containers, making them as hard enough for another person to figure out how it was made is very hard. And just to jump down to the last question about the needs and expectations around handling containers for preservation. The question that we had was, are Docker files enough, or do you need an image? And if you have an image, does that sign you up for running a registry? So some questions there, and then it would be great to have a way to periodically rebuild the containers, identify things that are broken. But then there may be cost issues with this. So I'll end it there.
Okay, and the room number, thank you. And the room number 4. Anyone from the room number 4?
Maybe that was us. I don't know. I can volunteer, but we didn't really. We didn't really discuss encapsulation, I'm afraid, because we were really newbies on this subject. So we discussed about the state of affairs regarding research data on repositories in Norway and France. So maybe no elements. If Craig wants to add something.
Yeah, that was group 5, and it was encapsulation was not the topic, so we focused more on just the discussion of the adoption of these repository software like Dataverse and the capabilities, these types of capabilities being available these days. So.
Okay, that's very much fine. Of course. So yeah, thank you very much. Maybe we can okay, so I just want to correct myself. So this like social event is like tomorrow at the closing. So it's going to be 1 p.m. Eastern. I don't know if anyone wants to join. They're welcome. And yeah, I also like pointed out what are the next steps for us. So like this kind of discussions. So if you if you have any ideas or want to collaborate, please reach out. Feel free to reach out to us at yeah, anytime. And I don't know. So maybe if anyone has like any question, we still have a little bit of time, and I'm super happy that we actually kept this like on time. And
Thank you for moderating. It was great, Anna.
Thank you. I was just like, I'm so grateful, but I'm also, it was a little bit scary to moderate.
So a burning question for you, Anna, from the opening, which is, I think you mentioned that IQSS received Sloan funding specifically to address the container question in Dataverse. Can you at least link to more information about that, or I hadn't heard that.
Yeah, it has just been approved yesterday. It's just like really new news. So maybe Marseille wants to say something about it.
Yeah, we're gonna share more information. I mean, well, it is, but it's address the points that Anna already presented in that one slide. But I think it might be easier to just put that we will consolidate a summary of the proposal. What are the deliverables are, and post it in the website and discuss with the team. Since it happened so fast during the community meeting, and I've been in sessions all the time, I haven't discussed it with the team much, so I would like to do that before and then post it publicly.
Great, no, that's fantastic news. I'll be very interested to see what you guys are doing.
Yeah, we're really
congratulations.
Excited. But we've been working on this topic for a while. I think the question now is to how we make, well, is a follow up on this in terms of making the containerization. Well, for one thing, making the deposit of code more easy to Dataverse in a way that it's better, that it has proper metadata associated with it, and leverage a lot of the work that has done on software citation, code metadata, and so to bring that metadata associated with the code. And the other part is the containers or the preservation of those containers in a way that we can check more when there is code in the container, does it actually execute? What are the prompts that we could give to the either the researcher or the data depositor about is that reusable? Would it run? Well, again, does it have enough metadata that describes the connection between the data, workflows, code, and so. And we're thinking about considering the research, the arrow crate metadata and research objects. So the way of bringing that together, which I know, Craig, that you're using, right? So.
Yeah, I think we're in RO. We haven't moved to crate yet, so yeah.
Okay, yeah. So would like very much to talk to you. Discuss. Well, I mean, in a way, we were thinking about it. Many of us are doing something similar. We could standardize, well, some form of standardizing it, or thinking of what are the best practices of doing that for repositories or other reproducibility platforms that are trying to use the same with the same tools, are planning to use containers and disseminate them and preserve them, right? So how. Yeah. And part of that's what we want to create a working group. Maybe now I'm talking too much about it, but I will follow up on this. But we would like to, and Anna will lead a lot of that effort. But about creating a working group that could focus on standardizing some of these practices across different.
That's fantastic news. So, great.
So in addition to this summary of the project proposal, we will also release this community notes and point to them somewhere. So if you have any final comments or any questions, you can also obviously put them there, or somewhere else. Also maybe open a Dataverse issue or something. So this community is very transparent and open to feedback. So yeah, I think that maybe we can like wrap up there. Thank you very much for everyone, and also thank you, Kate, for being so patient and bearing with me and keeping the time and creating the rooms and everything.
Great. Thank you all.
Bye bye, and have a nice week.
Bye.
Thank you.